Averages and measure of spread. Basically, why would I say need that? Yesterday, some student were asking, may I skip chemistry? So if you want to become a doctor, then no, you need to study chemistry. So for your goals, you need to see what you need.
Yes.
A quick recap. Do you remember stem and leaf?
Yes.
So averages year 9 mathematics mod was the value which occurred the most frequent. Let's while we are discussing this, let's have a look at this table as well if we can find those values. So I'm looking at right hand side and I see these two fours next to each other. And when I look at the key, 79 means is 79. So this would mean 94, 94. So in class B, the mod is 94. And then when I look at left hand side, what do you see? What is the mod?
I see two numbers. I mean, they're repeated twice, so it's 99 and 101.
Yeah. So we will either write that there are two most occurring numbers, that is 99 and 101, or we would say there's no mod.
Oh.
So median is the middle value, and that was the easiest at all times. Either we are talking about raw data or tabular form or this, because middle number, for example, but this question is not telling us that how many are there. Sometimes it would say that there were 20 students. So we can quickly count. This is, I'm counting class B, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So when it is 13, I know that the seventh number is going to be the middle number. So this would be 1, 2, 3, 4, 5, 6. Seventh number is 94. So I would know that median is 94.
And then when it's even, it's going to be the, let's say 12. It's going to be the fifth and sixth numbers, right?
Yes. So we'll write fifth plus sixth divided by 2. And when we are talking about the raw data, we will have to arrange it in order for median only. Then we can do all the others mod and average without arranging. If the question is about median only, then we will rearrange. So different type of averages. These are different type of averages, which is like mean, median, mode, and we'll see on what type of data, what type of average should we use. For example, if you're talking about salary of someone at the factory, so there are workers who has like let's say 10 to 12,000 salary, and then there's a manager whose salary ranges from 55 to 65. Now, it would not be a good comparison if we add salary of all of these person. If we are taking the average, that will actually raise the average high because of one person. So in that case, we might consider median value, or we might consider a mod.
So it depends
Or
on like the circumstance, which one you choose.
yes. So for example, if you have a math test at school and there are 20 students and one student scored 90 on 100. After that, the second highest score was 55. So if we just say that 90 on 100 student was absent, highest score is 55. Now that will not be wise to consider him and find the mean. Maybe because of that 95, the mean comes out to be 70. And the reality is that all of the class lies below 55. So in that case, we also call it outlier. That is where we will study those box and whiskers. I'll quickly make that sketch. This is the first value, then lower quartile, median quartile, upper quartile, and this is the upper value. So basically, sometimes if this is long enough, we would say this is an outlier. So we basically ignore this value and then solve for the remaining data.
So all of them have to follow a specific range, and if it doesn't, then you don't include it.
Yes,
Okay.
that also happens in your real life exam. If someone is very, very good, they will be considered as outlier. That won't affect the grade of other students. When
Mm.
Cambridge or any board is deciding about the grade threshold for A star and A and B. Okay, let's start. This is different types of averages. Average is a single value used to represent the set of data. Definitely, when we say that the average score is 22, you would always know that there are few students who scored more than 22 and few who scored less than 22. So it is a single value used to represent the set of data. There are three type of averages used in statistics, which we'll be studying: mean, median, mode. So when total number of numbers divided by number of numbers, this is mean. The mean value tells you that the shoe size appear to be spread in somewhere around 6.05. So these were the values. 19 students in class, their shoe size, and we took that mean. So it is some value above it, some value below it. The mean is sometimes referred to as measure of central tendency. So I would call it a vocabulary because they're one and the same thing. So if the question says that find the central tendency, that means mean.
So
If the question,
there's average, there's mean, and there's central tendency.
there are three type of averages: mean, median, mode.
Mhm.
Mean
But the
is the
vocabulary.
central tendency.
So they're the same thing. But
Mean and central tendency is same, yes. And
average is
while
a general name for mode, median, and range.
mode, median, and mean, these are three different. Let me write it.
Not.
Mean, one;
Mm-hmm.
median, two; mod, three. Let's say we are talking about mm, you went out to buy a coat for winters, and you would tell your parents that the mean price is $750. So they would understand that it is like suppose 900 and 650 something. So average price, or maybe they'll consider that this would lie between 700 and 800. And then you can say that I'm in this market, and the middle value is basically, or let's say you are buying, what are you buying? Car. You're buying a car. So, okay, shoe or car. So you just tell them the median size. Now, in this case, you might be considering parking space as well. And when we are talking about mod, we can also talk about elections.
Mm.
If we just don't mention the number of votes casted, but we can say that this party has been casted the most votes. So that is sufficient to explain. So mean, median, mode, these are three type of averages. And central tendency is just another word for mean. So now we are talking about median. We arranged the same data in order and selected the middle one. And when we have two in the middle, we add them and divide by two. That was a coincidence that we have both of them as six. They
So
could
there's
be different.
mhm.
Dealing with extreme values, outliers. Sometimes you may find that your collection of data contains values that are extreme in some way. For example, if you were to measure the spread of cars as they pass a certain point, you may find that some cars are moving unusually slow or unusually quick. It is also possible that you may have made a mistake and measured the speed incorrectly or just written the wrong number down.
So for experiments, it might be like that. Anonymous results.
Anonymous result. That would again depend what type of data you're collecting. When I said that one student in your class scored 90 by 100, and then the second highest scored 55, there wasn't any anomaly in your mind. There wasn't any question because this is quite possible. So this is the type of data. For example, this same question for speed of cars, you are measuring the speeds and you record 67, 68, 62, 59, 69, and so on. And then there comes the speed 125. So if you're showing this sheet to your teammate, they might say that maybe you've made a mistake because everyone knows that the speed limit here on this road is from 50 to 70. Why would someone pass at 125? Or why is someone driving at 17? Maybe the car coming behind this would hit him because
So
this is a highway for 72. So there is a chance that we might have made a mistake or the speedometer we're using, the gun we're using was malfunctioning. So that depends on the type of data, that it is an error or that is a real value, but we skip that out of calculations. So you see, this is an outlier. All those speeds are more or less close to each other. So one particular value will catch your eye immediately, which is 128.9 kilometers per hour, seems a somewhat faster than any other car. How does this extreme value affected your averages? Now you might be telling that you saw one Ferrari passing through. You saw a
but
sports car passing through. That is something if you get a chance to explain. But if you're not there, if you collect this raw data, or if someone else is collecting a raw data, and now you have a page in front of you. So you have your measures to make corrections in that data. We will not be doing that part. That is not in A levels. That is not in A levels. But yes, if you choose statistics in future, you would study those. So you can check yourself that the mean of the above data, including the extreme value, is 70.7. It's actually more than every other value. And if you ignore it, the mean is 59.
so
So this,
there's a drastic difference,
mm,
basically.
yes, because of that outlier.
So
So
we
if you
can't
just go on.
so we can't change like our whole entire like, for example, averages or mean or mode just because of one extreme. We need
Yes,
to find like the
yes.
truest answer.
Now, if you just ignore this, if this value was never there, then the average is 59. See, the lowest value 49 is somehow close to it, and then the highest value is 67 is close to it. So it is around 59. If the extreme value is genuine and cannot be excluded, then the median will give you a better impression. See, when you're backing up your data, you've collected it and you give them the reason how is it high. And you're telling them that is this is a true value, this is not a mistake. Then we use median. I'm taking a example in parallel. For example, the salaries were 10,000, 12,000, and 125,000, and then 10, and then 11, and then 9. So if we just take a mean, I'm quickly doing it. 10 plus 12 plus 125 plus 10 plus 11 plus 9, and I'm dividing it with 6. I'm getting a mean of 29,000, 29.5. So if you just publish this in newspaper that factory XYZ has a mean salary of 29.5 thousand, all these worker will burst in anger. That how is the salary 29.5? So mean is not the correct average to use here. If we arrange them, this is 9, 10, 10, 11, 12, 125, because this is not a wrong value. So average would be 10.5. This is a good representation. That 125 may be the salary of a general manager.
Oh, and then it won't cause any conflicts.
Yes. So in this case, we'll use median. And when they are more or less close to each other, we can use mean.
So when we're 100% sure that all of them are correct, including the
Yes.
highest one, then we use median. Okay.
Yes. Worked example, after 6 tests, Graham has a mean average score of 48. He takes the 7th test and scores 83 for that test. What is Graham's total score after 6 tests? So we know the formula. Mean is sum of numbers over number of numbers. So we know the score was 48 already on 5 tests. So when I multiply 48 by 5, I know the total for 5 tests was 240. 240 already, and then he scored 83 on his 6th test, and we got 823. 323. What is Graham's mean average score for 7 tests? Sorry, this was 6th test. I wrote for 5. So 48 into 6 is 288. Now 288 plus 83 gives me 371. Now average for 7 tests is simply total of 7 divided by 7. 53.
Why do we why do we add the 288 with the 83?
288 with 83, because in B part he's asking for average of 7 tests. 288 was a total of 6.
Mm-hmm. Yes, yes.
So in A part he asked for 6, that was 248 into 6 simply. And then he's asking about 7 tests. So total of 6 was 288 and 7th is 83.
So we just add, okay.
Yeah, that is given here, 83. So we know the total of first 6 tests was 288, 7th is 83. For each of the following data set, calculate the mod, the median, the mean. So there are these 4 parts. Let me zoom in and let's try for this first one, A. We do need to calculate the median as well. So let's arrange it in order first, and then we'll solve for all other questions. So I can see the smallest value is 2. Then I can see 3,
5,
no, 4, 5, 6,
6, 9,
9,
10,
10,
12, and then another 12,
12, 2 times, 12 and 12,
and 13.
and 13. So these are 1, 2, 3, 4, 5, 6, 7, and 9 values. 1, 2, 3, 4, 5, 6, 7, and 9 values. So
Is 12.
mod is 12. Then median.
9.
9. Yes, middle number is 9. So median is 9. And the mean. Now we're going to add up all these numbers. 2 plus 3 plus 5 plus 6 plus 9 plus 10 plus 12 plus 12 plus 13. I'm getting 72.
Divided by 9 answers. 8.
Divided by is 8. So mod is 12, median is 9, and mean is 8. Now in this case, if someone would ask, we can tell the median and mean as well. Both will be accepted. See, there's no outlier. My first choice would be mean because mean would represent every number. Mean is calculated by taking every number into account. And median is the middle number. For example, if I say 51, 50, and 49, if we talk about these three numbers, what is the mean?
50.
Mean is 50. What is the median?
Also 50.
Also 50. Now, if I say one of the number is 0, then 50, then 100, what is the mean?
The mean is still
I
50.
Still 50. I think, yeah, still 50. And the median is 50
Median.
again. So basically, from the middle value, the spread up and down is equal. So
Mhm.
more or less, like I can't say that this is an outlier. If I say 100 is an outlier, because why? Because it is 50 units at the higher end. So do we have a 0 at the lower end. That makes a proper bell curve. So, but if I say that 49, 50, and 100, now what is the mean and what is the median?
Equals to 66.34.
66.34 and medians is still 50. So see, when the data changes, now in this case, mean is actually incorporating every value. Median is not thinking about this 100. See, median was already 50. When this 51 is changing, median is not changing. So mean is the better representation which takes into account. And when there's an outlier, when there's very large or very less value, then the better option is median. Question number 2. Look carefully at the list of values in part A and D above. What is the difference? How did your mean, median, and mod change? This is somehow similar to the discussion which we just did.
Oh, yeah, that one has an
Well,
extreme.
this
Yeah.
43.
Mhm.
So this will not change the median, but it will increase the mean. Andrew and Barbara decided to investigate the television watching pattern and record the number of minutes that they watch the television for 8 days. So Andrew is recording, Barbara is recording. Find the median number of minutes spent watching television for Andrew and Barbara. So these
Sure.
are 1, 2, 3, 4, 5, 6, 7, 8. If we can just if we can just do it without rearranging, smallest number called off, highest called off. Then 38 and second highest. Then 40 and 125. So I'm left with 43 and 50. 43 and 65 by 2. Do you agree?
Yes, because those are the two left. Because it's an even number.
Yes, so that's a 54. Now let me cross out two small numbers. This is 10 and 15 and two high numbers. These two. Then another small number is 25, another high number is 90. So I'm left with 65 and 32. 65 plus 32 by 2. 48.5. So we're done with median. Find the mean number of minutes spent watching television for each Andrew and Barbara. So basically, we'll add all of those numbers and divide with 8. Find a list of 5 numbers with the mean that is largest than all but one of the numbers. Find a list of 5 numbers with a mean that is larger than all but one number. Okay.
So it's still like the extreme.
Yes, it is still the extreme. For example, we have 1, 2, 3, 4. So I need to have 5 numbers. So I'll
If
take the fifth number large enough so that the mean is greater than 4. So I'm just considering it x divided by 5. Now I know the mean should be greater than all numbers, but 1. So I can say that this mean is actually greater than 4. So I'm reverse calculating it. So 5, 4 times 20 and 1, 2, 3, 4. 1 plus 2 plus 3 plus 4 is 10. So I'm making x greater than 10. So now you can choose any number greater than 10. 1, 2, 3, 4. And any number greater than 10 will give a mean which is more than 4. So this is like one of the list. Everyone may have different response. They may select 10, 11, 12, 13, and so on.
so the answer marking sheet is just going to say above 10.
No, the examiner would check it individually. This was my choice. So I wrote 1, 2, 3, 4, and 11. Now, do I fulfill the requirement of the question? List down 5 numbers. I did so. With mean, if I find the mean 1, 2, 3, 4, and 11 divided by 5, mean is 4.2, which is larger than all but one of the number. So 4.2, yes, it is larger than all of these but one. So this is my list. Is this fulfilling the requirement of question? Yes. Someone else may have this 10, 11, 12, 13, and then an unknown, and they'll use their calculator and quickly type 10, 11, 12, 13, 4, 1, 2, 3, 4, and divide by 5. Now I'm checking for the last number that is hit in trial. Even with 15, I'm getting number less than 13. So if I try 20, I get 13.2.
So above all.
Yeah, so if I take that list, I can have 20 as the least number. In this case, x would be 20 or more than that. cannot be 19 because mean comes out to be 13 if I take it 19. A keen 10-pin bowler plays 5 rounds in one evening. His scores are 98, 64, 103, 108, and 109. Which average mod median will be choose to report to his friends at the end of the evening? Explain your answer carefully, showing all your calculations.
Well, there's one that's very low than all the other ones, so median.
64. You're talking about 64. Now, personally, actually, I'm thinking about the game. Which game is it? 10 full baller plays 5 rounds in one evening. If we talk about the median, this is going to be 103. Ninety-eight, 48. That your answer is right. 126, which is actually lesser than all four of these. Question number 6. If the mean height of 31 children is 143.6, calculate the sum of height used to calculate the mean.
Oh, so just no, yeah, so just basically 31 times 143.6.
Yes. Answer is 4451.6. Question 7. The mean mass of 12 bags of potato is 2.4. If the 13th bag contained 2.2 kg of potato is included, what would be the new mean of 13 bags? Can you do that? It is 2.3846.
Yes, 2.385. I
We
got
should
four.
not have any difference.
Yeah, I did get 2.3846.
Okay, okay, you rounded it. Okay, 385. Very good. Very good. The mean temperature of 10 cups of coffee is 89.6. The mean temperature of different collection of 20 cup of coffee is 92.1. What is the mean temperature of all 30 of these cups?
So it's all different collections. Oh
The
no, all of them
20.
together. Yeah, both of them together. Okay.
Yeah.
91.3 if I round it up.
Very good. So basically, you know how to handle this. What we do is mean of first into number of first plus mean of second into number of second. That gives us a grand total divided by number of first plus number of two. This actually gives us combined mean. Did you use this or just individually found the total first? Find the set of 5 numbers with mean 5, median 4, and mod 4. Mean is 5, median is 4, and mod is 4. So that's a hit and trial question.
Mean 5.
Yeah, and students may have different responses. We have to fulfill the demand of the question. Find the set of 5 numbers. Mean would be 5 and median is 4. So if
So some
median is
has to
4,
be 25.
I now know that very nice that this should look like this. And also that, yes, sum is
We already
20.
know, so all the other ones has to be 21 as well.
Median is confirmed 4, so I know this is 24. This is 4. And one more thing, mod is also 4. So there
Two.
must be one more 4. Now, in order to keep this 4, I cannot have with this number if I write x, y, and z. I cannot have z less than 4 because median will change. Getting the point?
Yes.
So whatever x and y is, it is less than 4. So 25 minus 8 gives me 17. X plus y plus z is equals to 17. Now let me say that this z is actually 5 because it has to be more than 4. It could be anything. I'm just assuming 5. So if I do so, this becomes 12. And when we divide it with 2, this becomes 6 and 6. So that's not an option. I should
Can
have these two numbers less than 4.
can it be 2, 2? So X and Y are both 2 and
Yes, yes, yes.
is 5.
So we are increasing this z. So 2, 2, 4, 4. Now 4, 17 minus 4 is 13 is equals to 25. 2 plus 2 plus 4 plus 4 plus 13 is 25. Mean is still 5. Median is still 4. And mod is still 4. So this is one of the list. Now, if we have these, if I quickly make few adjustments, if I say this is 1, this is 3, 4, 4, and 13. So still median and mean and mod are the same. So we may have different responses. But what we cannot do is we cannot have this number less than 4 and we will not have these numbers more than 4 or else we would have to readjust them to change the mod.
For median purposes.
Yes. One more question. This exercise is completing. The mean mass of group of M boys is X kgs and mean mass of group of N girls is Y kgs. Find the mean mass of all the children combined. So we just plug them in the formula.
Yeah. MK plus NY over MN. M
Yes.
plus N.
Okay. So I hope you forget to send that email again today.
No.
Like I'll get time to check it on Monday, inshallah.
Okay.
So, but do share it and
Okay.
making comparison of averages and ranges. This is a new topic. And I think no homework for today.
Oh.
We've already completed all those questions. And this was sort of a recap, right?
Mm-hmm.
It's just increasing the difficulty level of questions, more of assumptions.
It's very easy
Less
because I've done
calculation.
this for like 3 years.
Check it in 1 max 2 days.
Okay.
Okay, so we did this exercise, and then now the next topic is making comparison using averages and ranges. Having found a value to represent your data in average, you can now compare to. So yesterday we concluded that whenever there's an outlier, we will go for median. So having found a value that represents your data average, you can now compare two or more set of data. However, just comparing the average can sometimes be misleading. We've been through those values as we've just changed few values and the median never changes. And sometimes there is a slight or more change to the mean. It can help to know how consistent the data is. And you do this by thinking about the spread out of the values. Consistent would mean just like the example we did that the cars passed with this much speed. They were
So
around
how
60.
much it repeats itself basically.
Yeah,
Like how much it keeps on doing that.
yeah, more precise, less spread. So a simple measure of spread is range. Range is the largest value minus smallest value. The larger the range, the more spread out the data is and less consistent the values are with one another. We may also call it less reliable. So two group of athletes want to compare their 100-meter sprint times. Each person runs once and records his or her time as shown in seconds. So first team 14.3, 16, 14, 17, 14, 15. Second team 13, 16, 14, 14, 13, 16. Calculate the mean 100-meter time for each team. Oh, that's a worked example. Let's use that. So it's already calculated. We added all those five, 1, 2, 3, 4, 5, 6, and divide by 6. So mean of first is 15.48. Mean of second is 14.87. Which is the smaller mean? Obviously, the second one. What does this tell you about the 100-meter times for Team Python in comparison to those for Team Socrates? Your comments.
Well, they had less amount of time, so they did better on the 100-meter sprint.
Very good. So the team did better. They faster. Calculate the range for each of the team. Let's do this. So for the first one, I can see the highest value is 17.9 and the lowest is
3.1.
14.1. And I'm getting a spread of 3.8. So range for each of them, first one is 3.8,
And then second one is 3.6 with 16.8 and 13.2.
3.6. It's getting stuck. Let me reopen it quickly. So you calculated the ranges that was 3.8 and 3.6. I don't know what's going wrong. It's still getting stuck. Yeah, better now. So 3.8 and 3.6. What does this tell you about the performance of each of the team?
Well, for Team Pythagoras, that means they had like a larger difference between their highest and their smallest. So that could mean that their smallest was either like
That's right. We'll use this vocabulary, consistent word, the word consistent.
distant.
Second team, Team Socrates are more consistent. Exercise. Two friends, Ricky and Oliver, are picking berries. Each time they fill a carbon carton, its mass in kgs is recorded. The masses are shown below. So Ricky filled with these masses, Oliver filled with these masses. For each boy, calculate the mean mass of berries collected per box. Let's do this, then we'll skip the similar ones. 0.145. Do you want me to zoom in? Can do that.
Um,
Have
okay.
add space. Yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 entries for Ricky. I'm getting for Ricky 0.1515.
Hmm. Yes. 0.515. And
So we're
then the
getting
range.
the same answer.
Mhm.
Next one quickly. 131, 143, 134, 145, 132, 123. I'm actually adding all of these numbers without decimal. And 182, and 134, and 128. And then dividing by 1000 finally. And this is 1, 2, 3, 4, 5, 6, 7, and 9. And for Oliver, I'm having 0.139 and all the ones.
0.1. 0. I think I miscalculated. I got 1.23.
1.23. I'll
I
also
don't.
do it again. 131, 143, 134, 45, 132, 123, 182, 134, 128 divided by 1000. And this is 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm getting the exact same answer, 0.1391.
Yes. Okay.
Got it?
0.139.
Same answer. Range of masses for Ricky and for Oliver. So the highest value 0.18, 0.20,
201.
201. And the smallest is 0.135
112.
to 0.1120.
0.112.
0.112, yeah. So this is 0.089.
89.
And for Oliver, 131, 123. 123 is the smallest value and 0.182. 123, yeah, and 0.18.
0.059.
0.059. So Oliver has lesser mean and lesser range, and Ricky has a greater mean and greater range. So which boy collected more berries per load?
Ricky?
Yes. Which boy was more consistent when collecting the berries?
Ricky.
Consider that again.
Oliver. Oh, because it's less.
Less range. So his berries were more or less close to each other in weight. Now let's skim through questions. We'll just skip that physical exertion part and see if the question has a different nature. The marks obtained by two classes in mathematics test are shown below. The marks are out of 20. First class and second class. Calculate the mean score. Exact same method. We add them all and divide by the total number of students.
Or
Find the
median.
sorry, I read mean. So median, let's do it. Median score for each class. So one thing is we arrange them in order. 4, then all are two-digit numbers and smallest being 12. 1, 2, 3. So 12, 12, 12. Then I have 1, 2, 3, 13s, 13, 13, 13. Then I have 16, 18, 19, and 20. So 1, 2, 3, 4, 5, 6, 7, 8, 9,
Cheating.
11 students. So this is the median for first class. 13 is median. And arranging the second one, the tree, 20 being the largest. Then I have 6, 9, 13, 1, 2 times. Then I have 15 2 times. This is 15, this is 15, and 17, and 19. Crossing out actually confirms that we are not missing any number. So again, the middle number in this case is 15. Find the range of scores of each class. We've already arranged them in order. These are Archimedes and these are Bernoulli's. So difference between 20 and 4 is 16
16.
and 17. C part says which class did better in test overall.
uh, Archimedes. I think that's how you say the name.
And
Because
why is that so?
like wait, but their median is smaller. So no, class Bernoulli because their median is higher.
Okay, if we compare the median, yes, they did better overall. Like half of the class is above 15. So D part says which class was more consistent?
Then it's going to be A.
Archimedes. A.
Yes.
So Archimedes is more consistent. Question number 3. 3 shops sell light bulbs. A sample of 100 light bulb is taken from each shop and the working life of each is measured in hours. The following table shows the mean time and the range of the shop. Okay, so mean time in hours is given and range is given. 100 light bulbs taken from each shop and working life is measured in hours. And the following mean, okay. Which shop would you recommend to someone who is looking to buy a new light bulb?
Footlights.
Sorry,
Footlights.
the second one, and why?
Well, but the consistency. Okay. Well, they scored the highest amount that they can go through. So
So
like
they
they
can
have the
light up to
highest.
145 hours.
Yes.
And if I just add 36 to 145, they may get lucky to get it 181. And 145 minus 36, this may be 109. So these are equal chances. And if we just compare 143 plus 18 is 161. On the other side, minus 18 is 125.
So that one has a higher lowest.
Yeah, we should recommend backlights. Why so? The mean is actually close to each other, 145 and 143, but the range is lesser.
So that makes it more consistent and better.
Yeah, that is consistent. Because if in shop footlight you choose a bulb, you might be getting the one which lights for 109.
So it's just backlights.
Yeah, they're not consistent. Whatever they are manufacturing, they're not consistent. So less reliable. Calculating averages and range of frequency data. So now type of data is just changing. The main concept stays the same. From raw data, we are going to tabular forms. So data shown in frequency distribution table. If you throw a single die 100 times, each of these six numbers will appear several times. You record the number of times that each appears like this. So 1, 2, 3, 4, 5, 6. And we are getting one a 16 times, two a 13 times, and so on. Now, how do we calculate the mean? Do you remember the formula
We're on a frequency table, right?
from the
Well, first of all,
summation fx over summation f, sum of frequency into x over sum of f. So how do we do it? This is 1 into 16 plus 2 into 13 plus 3 into 14. For the first one, I'm going to do it in complete detail. 4 into 17, then 5 into 19, then 6 into 21. And finally, we divided with the total frequency, and luckily it is already given that it is 100. Or else what we would do, we would add 16, 13, 14, 17, 19, and 21. So this is how we get the mean. Main concept behind it is that one is actually appearing 16 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. And that 2 is appearing 13 times and so on. So this is what we did. We added 1 a 16 times. We added 2 a 13 times. So this is the difference between raw data and frequency table. Got it?
yes.
Now from this same table, let us see what the mod is. What is the highest frequency you see?
21.
21. So the mod is 6. Now how do we find the median? These are 100 numbers. So we would know that the middle number will be 51st number and 52nd number. How many are these? The ones covered?
1. 16 times.
16. These are 16 numbers. And if I cover these numbers, how many are these now?
29.
These are 29. 29 plus 14,
Um, 33.
43.
43.
And then plus 17,
60.
60. So for sure, we are covering 51st and 52nd number in this. So that is 4 plus 4 by 2 and median is 4. So if I would write all these numbers, 16 ones, 13 twos, 14 threes, 17 fours. So the 50th and 51st number, sorry, this was 50 and 51. So 50th and 51st number would be 4 and 4. And that will be my median. Range, obviously, highest and lowest, the difference is 5. So mean, median, mod, range. Data organizing into a stem and leaf. You can determine average and range from a stem and leaf diagram. Yes, we can. Mean, median, mod, and range. Now let's see. The key says 0 2 means 2 customers.
So 2 1 means 21.
Yeah, I need to check he's adding or he's just writing next to each other. 2 1 would mean 21. Yes. So in order to calculate the mean, what can we do? 2 plus 5 plus 5 plus 6 plus 6 plus 6 plus 6, and then 11, 13, 13, 15, 15, 16, 17, 17, and 21. So we add all of these and divide by the total number of entries. We'll get the mean. Okay, let's go through these parts. What is the range? So maximum value is
So
21.
21 minus 2.
21
So
minus 2 is
19.
19. So because they are already arranged in order, what is the model class? Which digit do you see appearing the most?
6.
6. And it is opposite to 0. So the mod is 6. C part says determine the median number of customers served. So what do? We first count how many were they. How many did you get?
15?
Got 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I got 16.
Okay, then I think I missed out on this extra 7.
So if they're 16, we know that 8th and 9th number will be the middle numbers. So
So we just
1,
count up.
2, 3, 4, 5, 6, 7. So the 8th number is 11 and the 9th number is 13 and my median is 12. Clear? D part says how many customers were served altogether during the shift. We just counted them. They were 16. E part says calculate the mean number of customers served every half hour. So now we calculate the mean. I'm not writing, I'm just using calculator and punching the numbers here.
10.875.
Correct. Quick summary. Mod is the one against highest frequency. Mean is total of all data divided by number of values or number of entries. And median is the middle number. So if the data is odd, we can follow this formula. For example, we know there were 11 entries. So we can do 11 plus 1 by 2, which is 12 by 2 is equal to 6. So sixth number is the middle number. In case it is even, that means if they are already 12, so we just do 12 by 2, that is 6. And we would know that sixth and seventh are the middle numbers.
Hmm. So it just gives you the position of it.
Yes. 12.3. Construct a frequency table for the following data and calculate the mean, median, mode, and range. So as soon as the exercises are passing, he's just increasing the workload of the question. Nature of the question is not changing. Difficulty level is not increasing. So if I just have a look, I can see some ones, I can see some nines. So making it tally. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's use some extra space. It would be more organized. So this is 12.3. 1, 2, 3, 4, 5, 6, 7, 8, and 9. This would be X. This is tele, and then I have frequency. I'm counting only these ones. One, two, three, 4, 5, 6, 7. And I just counted all of them, so I'm just skipping the tele part as well. So, or let's do it, because if we miss one, we can add the stick to it. So this is 7. 2, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Threes. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now fours. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now going after fives. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Sixes. 1, 2, 3, 4. 1, 2, 3, 4. Those sevens. 1, 2, 3. I got 3 sevens. Then 8. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Then nines. 1, 2, third 9. 1, 2, 3. So filling up the tally 5, 6, 7. This is 5. This is 5, 9, 9, 4, 3, 5, 3. And quickly checking up the total. So 7, 5, 5, 9, 9, 4, 3 plus 5 plus 3. I'm getting a 50.
Mhm.
1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 into 3 plus 2 is 50. So it says find the mean. Now we've made the frequency table and we can find the mean. So mean is sum of fx over sum of f. 1 into 7 plus 2 into 5 plus 3 into 5 plus 4 into 9 plus 5 into 9 plus 6 into 4 plus 7 into 3 plus 8 into 5 plus 9 into 3 and divided by 50. This is 225 by 50 and mean comes out to be 4.5. Second one says the median. So we already know these are 50 and these are even. So n by 2 is equals to 50 by 2 is equals to 25. So I know I need to know the 25th and 26th value. 7 and then 7 plus 5
12.
is 12. 12 plus 5 is 17. 17 plus 9 is 26. So this just covered both of these. So the number against this is 4. Median is 4. The mod. Which one is the mod?
There's no mod or there's two mods. There's 4 and 5.
So we will always go for the safest side. We will say that 4 and 5 occurs the most. That is 9 times as the highest frequency, equal and highest frequency. Range. So range is maximum minus minimum.
So 8.
9 minus 1 is 8. Okay. Question 2. The ticket for the circus was sold at the following prices. They're given. Present the information in frequency table. Calculate the mean price of the table of the ticket sold. Okay. So ticket for a circus was sold at following prices. 180 were sold at this. 215 were sold at this. So basically prices would be represented as X. Let me just highlight the prices. This is 1, 2, and 3. So 6.5, 8, and 10. These are the X. Frequencies are given. 180 of these were sold. 215 of these were sold. And 124 of these were sold. So we represented it as frequency table. Then it says present done. Calculate the mean price of the ticket sold. So let's do it in calculator directly.
844,446.6666. That is not my answer.
Prices are 6.5 and 8 and 10 something. So mean would be around that.
Yes, but how did I get to the 100,000s, babe.
Divide it with the total as well, which is 180 plus 215 plus 124. That is 519. Formula for mean was summation fx over summation f. 6.5 into 180 plus 8 into 215 plus 10 into 124 divided by 180 plus 215 plus 124. I think you missed the denominator.
I think maybe 7.9576.
Yes.
Yeah.
Okay. A man kept count of the number of letters he received each day over a period of 60 days. So frequency total is already given. The results are shown in the table below. For the distribution, find the mod. And the mod is
Mode is 0.
0. Find the range.
The range is 5.
5, yes. So let's do the median first. 60 days. What would be our target?
Around 30 and 31.
30 and 31. So 28 plus 21. So for sure, the median is 1. 30 and 31 gets covered in this. And now the mean.
1.32.
I'm getting
So,
0.8.
okay. Uh,
I'm checking it again as well. Still getting 0.85.
0.85.
Yes.
When you did the one with the 0 to 28, you kept the 0, right?
Yeah, we keep the 0. 0 times 28. Basically,
So
this
it's
is
0.
0 is appearing 28 times. So how many times we add that? It stays 0. So
Okay.
we get 0 into 28 plus 1 into 21 plus 2 into 6 plus 3 into 3 plus 4 into 1 plus 5 into 1 and divided by 60.
And it gives us 0.85.
Yeah. 0.85. Again, mod, median, mean. Same type of question. Question 5 says mod median mean, and there are some extra questions. Let's see. So for this data, the distribution of marks obtained by the student in the classes shown in the table below. These are the marks and number of students. It says find the mod.
8.
8. 6 being the highest frequency is against 8. The median. So how many students are there is not given. I'm getting a total of 30.
Me too.
So we need 15 and 16. This is 1, still 1, 4, 6, 8, 12, 15. So now this time we have two numbers. 15th number is 6 and 16th number is 7. 13 by 2. Our median this time is 6.5. Mean. Let's do it slowly without making a mistake.
6.06 continued, so 6.1.
6.03 continues. I'm getting 181 over 30.
I already erased this, so I'm gonna redo it.
Okay, no issues. No issues. Let's see what the second part is.
Okay.
It says the class teacher is asked to report on her class performance and wants to show, okay, this was 6.03 performance and wants to show them to be doing well as possible. What average should she include in her report and why?
Well, she can include the mode
And why?
because it's the highest amount and it shows that a lot of people in her class got 8.
That's right. A lot of people are, that's right. The higher score and the more people are doing that. Question number 6. The masses of 20 soccer players were measured to the nearest kilogram and this stem and leaf diagram was produced. 4, 6 means 46 kilograms. So these fours are the tens and the leaves are the units. Redraw the stem and leaf diagram to make an ordered data set. So if you can see, they are not in order. So we do it here. This is stem, this is leaf. 4, 5, 5, 6, 6, 7. Okay. So he's broken these two. We can keep them as it is, or we can keep them as 1. 6, 6, 7. But that would be unfair. Let me keep them as 1. 4, 5, 6, 7. So against 4, there's only one value. Against 5, I can see the least values as 2 zeros. And then 4, 5, 7, and 9. 4, 5, 7, 8, 9. 4, 5, 7, and 9. Now the sixes. I have 1 0. I have two ones. And while I'm writing this, I'm making sure I write below the digits. Then we have two threes, 3, 3. And I missed that 2. Let me adjust it. 2, 1, 1, 3, 3. 2, 1, 1, 3, 3. I have 6, 6, 6, 6, 8, and 9. Then at 7, I have 0 and 4. So redraw. Then it says how many players have mass of 60 kg or more. So we just count that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 60 or more. 60 or more has are all these. Why is the mod not a useful statistics for this data?
The mode is in the 60s. There's three modes, right?
Yeah. So two zeros would mean 50 and two
Actually,
ones are
four.
for 61. Two threes are for 63.
There's
Two
many
sixes are for 66. So there are many mods.
that are
So that
ranging
is
from
why.
different.
Yeah. So what is the range of masses?
28.
28. That's right. What is the median mass of player? So first we count how many players we have. We've counted 12 of
20.
these already. 13, 14, 15, 16, 17, 18, 19. Very nice. So when we have 20, we know 10th and 11th are the middle numbers. 1, 2, 3, 4, 5, 6, 7, 8,
So
9. 10. This is the
62 and
number.
61.
What did I do? 2 is here and 1 is there. 2, yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10th number. So 10th
So
number is
61.
61 and 11th number is again 61.
61.
Median mass stays 61 kgs. So we have one question in this, and let me have a look. There's only one difference
Oh,
in this new
yeah.
exercise. For the mean only, we would use the middle number. Like the middle number in these two is 125. Middle number in these two is 135, then 145, then 155, and then 165.
And then we just times it by the
Times it
frequency.
by the frequency, yes. Nothing else changes. So I'll share this exercise 12.4 with you for practice along with answers.
Okay.
And percentile, not much is left. These questions would just take a lot of space, but the solution is very simple because they consist of graphs.
The same thing, like basically just repeating.
In 12.4, yes. In cumulative frequency, that's a slight different concept, but easy.
What does cumulative mean?
Sorry,
What does cumulative mean?
cumulative. What we've been doing for median, we're cumulating it. We did
Adding it
this.
together?
Yeah. How many are less than one? How many are less than these? How many are less than these? So what are we doing? We are adding all these frequencies. So I had to reach like for the median, what was it? Let's say about question 4. So I had to reach 50 and 51. So if I write cumulative frequency, I'll write 4 here because these are 4 families. And now I'll write 40 over here. 4 plus 36 is 40. So when I say what is like less than and equal to 40, so these are the all of these. Then 40 plus 27 gives me 67. So I'm covering 67 till here. Then 67 plus 21 gives me 88
Oh, so
plus
it's just adding
5
on.
is 93 plus 4 97, 1999 and 100. So cumulative frequency adds up to all.
But what's but what's the use for
We'll
adding
study
it?
we'll study it shortly. The next topic is cumulative frequency. I'll give you a quick example. For example, I ask you that how many of the students got 8 or more marks out of 10. So you'll add all those 8s and 9s and 10s. Sometimes, for example, you say that the qualifying marks are 8. So you just say how many of you got 8 or more than 8. Those students will raise their hand. So 8 and more than 8 is a cumulative frequency. But with that answer, let me say 7 students raise their hands. You would never know that all of these 7 got 8 marks or 9 or 10. So loss of actual data is also there. Whereas in stem and leaf, you have the actual data. Actual data is not lost. Like
So it's
this one in
basically
table.
added together, trying to find like from a certain point how much people got how much more.
Yes. For example, you are working on sports day and you say that all those candidates who took 30 seconds or less qualified. You were working on, let's say, single race. So 30 seconds or less qualified. So whoever is taking like 10 seconds or 28 or anything, you're not counting them individually. So that's a cumulative frequency. Some must have took 16 seconds. Some must have took 17 seconds. So irrespective of that, you are just fulfilling the criteria and you're adding all them, you're cumulating them.
And for frequency tables like this,
Yeah.
you're just basically trying to find the total, like by adding all of them together, like
Yes. So this is 1. 1 and 0 is still 1. 1 plus 3, 4 plus 2, 6 plus 2, 8 plus 4 plus 3 plus 4 plus 6 plus 3 and plus 2. Now, if
wait,
I
how did
say,
you get one and one again?
yeah, because I added
Oh,
1
wait,
plus,
isn't that zero?
yes, first one is 1, right? Now 1
Mm-hmm.
plus 0 is still 1. And 1 plus 3 is 4. 3 plus 2 is 4. We keep on adding the next frequency. The next frequency by chance was 0.
Mm-hmm.
That is why I got the same numbers.
Oh, you add the 6 to the 2 and you get the 8. Okay.
Now,
So just
if I say I'm just rejecting the first 15 students, so you would know they scored 16, they scored 6 or less. So if I say we are selecting students who scored 7 or more, that would mean 30 minus 15, we selected 15 students. If we say we selected students who scored 9 or more, so you would know these are 28 and so on. You would subtract this 30 and 25. You would know 5. So this is the use of
highest,
congruency.
highest, and then the one before the line. You
Yes,
subtract them.
yes. This depends on the scenario. For example, we are talking about the marks. Definitely, these students are selected. If this was a race, the lower end would be selected.
Okay.
So I'll share the next exercise with you for practice. Anything
Com was it comparative or something? Frequencies?
cumulative frequency.
Comparative. You showed me like just a little bit of it. Past class.
We'll do. I remember. Okay, so we have to do these. We did this in homework. Was there any confusion in homework?
Homework?
Oh, I think I shared some practice material. Let me display. Let me
Mm,
check the last one.
anything?
Let me see. Yeah, this one.
My dad didn't send me anything. The only
Yeah.
thing that he sent me was to like review the questions on the test and like do the right ones, but
I think I sent this first and then the other file. So maybe he would have mm, missed it or thought
Did you send this to my email or my dad's?
uh, the WhatsApp group
So yeah,
which the organizer has made.
I don't know. Maybe my dad forgot to send or something because like he just sent
Mm,
me to review the test.
I
That's
sent
it.
that Monday, this task 18 on Monday and test 4 on Tuesday. No issues. We'll do it now.
Okay.
Okay, then there was this note that these are exam style questions. Just so you would know that this is the actual question which was in one of the exams. So this is the difficulty level. Whatever we are doing in book is actually of higher order and it is easier in exam. The table shows the height of 50 sculptures in an art gallery. Find an estimate for the mean height of sculptures. So mean height. How do we find the mean? Do you remember that?
So we find the midpoint of the ranges basically,
That's correct.
30 and 135. And then we times it by the
We'll write X
frequency.
and F for ourselves first before we continue, just to make it easy for ourselves. F is already there. Let's write X. So 130 and 135. What is the midpoint?
It is uh, 113.4045.
132.5.
130.
There are two ways you add them both, 130 plus 135, and then divide by 2. So you'll get 132.5. Or you can just see the differences of 5. Half is 2.5. So we add 2.5 to 30.
132.5. I was rushing it because I was trying to do it as quick as possible with two. I was doing
It's
265.
a very good thing you admit it.
So yeah, 132.5.
And next one is
Same thing, 140. 137.5. Yes.
good. So I'm writing it. Have a close eye on this. 140 and 145 is 142.5. 45 and 50 is 147.5.
And
150 and 55 is
2.5.
152.5. Now, in this case, we can clearly see that all the differences are of 5. Sometimes it's not the case, and we will be plotting frequency densities. Now, the question was about mean height. So, mean is sum of fx over sum of f. So, we can see f and we can see x. So, 7 into 132.5 plus 13 into 137.5 plus 15 into 142.5 plus 11 into 147.5 plus 4 into 152.5 and divided by, we would have added the frequencies, but the total is already given. So 50. Now, where the next mistake could be is punching the button in calculator. Do you have it with you, calculator?
Yes, I do.
Let's do it and match our answers.
7 times 132.5.
Yeah, are we getting the same answer?
Um, 2 seconds by 50. Yeah, 141.7.
Okay. Question number 2 says the table shows the length of 100 telephone calls. Calculate the estimate of mean. Now, this table seems simpler than the one at the top. Now, I'm going to do it without writing x for myself. So, mean is equals to sum of fx over sum of f. And I'm selecting the midpoints directly. 0.5 times 12 plus 1.5 times 14 plus 3 times 20. Now notice that they are not equal intervals.
Well, yeah, they're changing them like as they're going up.
Yes. 7 into 12, 9 into 18, and this is 12.5 into 10. And the total is 100.
5.28.
5.3. B part says write your answer in minutes and seconds to the nearest second. Now I'll wait for you to convert this.
Well, it's already in minutes, right?
Yes, that's already in minutes.
So 5 minutes. And then the seconds part.
Yes.
Do we have to do anything to it? I was trying it out with like the 28, but
This is 5.28 minutes already.
so it's five
So that
minutes and
means
28
5
seconds.
minute clearly. No, this is not 28 seconds. This is 0.28 minute.
Oh, okay. So it's 16.8.
16.8. So when we write 16.8 seconds, then to the nearest second, what did
So
it round
17.
up? So this is 5 minutes and 17 seconds. Question number three. Calculate the estimate of mean temperature in the tubes. I'm getting 57.4.
Yes, 57.36, which is rounded to 57.4.
Question number four says the athletics team and the Hawks and Eagles are about to compete in a race. The masses of team members are shown in the table. Okay, so brackets are same and frequency is different. Calculate the estimate of mean mass of each team. Hmm.
So first team was 76.7 and then second was 78.4.
Correct. So calculate the estimate of mean of each team done. Then it says calculate the range of masses of each team. So for the Hawks, range of masses for each team would be same. Maximum mass minus minimum, maximum minimum. Let me quickly check. This is question 4B. Yeah. So we can see maximum for both of them is 100. Hawks and Eagles, both is 100. Maximum minus minimum. So we get 45. Comment on your answer for A and B. If I may draw this for both of them, we know both are starting at 55, ending at 100. The next one again is at 55 and 100. And we can clearly see that mean mass of first team is 76. Let's say it lies here, 76.7, and the other one is 78.4. So range is same, but the mean of second team is more. So I can say that they are heavier because when we look at the Hawks from 55 to 65, it's written 2. But we cannot say both of them are either 55 kg or 65 or 64. It is unclear, but whatever their mass is, it is between 55 and 65. So generally, this mean shows us that the second team, Eagles, is heavier, more in mass than the first team. Question number 5. The table below shows the length of 50 pieces of wire used in physics laboratory. The length have been measured in nearest centimeter. Find the estimate of mean. Both of these questions are again for mean. I think um, take a screenshot and do practice this with along with the answers. Is this readable or take two? Take this screenshot. Question
Okay.
5 and 6. Done. And these answers for 5 and 6. Now let's continue with our next task. Percentiles and quartiles. So let me explain it here. Percentiles and quartiles, basically percentiles would be from 0 to 100. Like examiner could say anything, 10th percentile, 12th percentile, 90th percentile, 60th percentile, anything. And quartiles, we have 3, Q1, Q2, Q3. Q2 is also known as median. Q1 is known as lower quartile. Q3 is known as upper quartile.
So out of all your scores, so if you did like 3 tests,
Values would be given. So we take lower quartile, upper quartile, and median quartile, and lower quartile is at 25% of total. Upper quartile is at 75% of total and median quartile is at 50% of total. For
Oh,
example, we have this graph and I'll explain this graph later. I'm just explaining these quartiles. Let's say this maximum value is 80. So it is from 0 to 80 and on the other side, this is from, let's say 0 to 50. And let's say these were number of students and these were the marks they took in an exam. So when examiner would ask you about the median or Q2 or middle quartile, so we will work out the way to 50% and this will be my answer Q2, whatever value is here. And when the examiner will ask about upper quartile, so we know that upper quartile is 75% of total. Either we write 75 or we write 3 by 4 means the same thing. And this comes out to be 60. So we come at 60 and we read this value. This is as Q3, upper quartile or Q3, Q1 or lower quartile. So lower quartile is at 25% of total or 1 by 4 of total. That is 20. So we read the value against 20 and this is Q1. So whatever value is that, we write it here. And then we have inter quartile range, which we also
oh.
write as IQR.
So
So
difference
in
between different quartiles.
very good. Upper quartile and lower quartile. So interquartile range basically covers 50% of the data. Upper was 75, lower was 25. So this is from 25 to 75, which is 50%. So when it is covering all this, this actually represents the middle 50%. So this is interquartile range. So these are quartiles. And what about the percentiles? For example, we have the same graph and this was 80 and this was 50 and examiner says find 60th percentile. So what would we do? 60 by 100 of total. And this comes out to be 48. Now we'll find where 48 is and read the value against this. Now this is my 60th percentile.
So
These were
it's
percentiles. Sorry, go on.
so it's a student, right? The 60th percentile, like, is the score of a student.
Yes, we would definitely have B and C parts. For example, if the examiner says that 60th students after 60th percentile pass the exam. So we would know that what is the cutoff mark. For example, let me say this is 27. So we'll know anyone with 27 or more than 27 passed the exam. And if this was a race, then 27 or less than 27 would have passed because in race, lesser time is qualifying. So these were percentiles and quartiles. And how do we get this graph is known as cumulative frequency. Now let's go through it step by step. So percentile could be anything. That is simply percentage equivalent to percentage and quartiles is lower, middle and upper.
Before we begin, can I quickly get water?
Sure.
Okay, sorry.
No issues. And then we talked about interquartile range, which is Q3 minus Q1 or upper quartile minus lower quartile. We discussed it against cumulative frequency graph, and we can do the same in raw data. For example, let's say we have some values A, B, C, D, E, F, G, H, I, J. So if someone would ask me the median, so I should know how many values are these. These are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these are 10 values. So I would know 10 plus 1 by 2, that is 5.5. That means a fifth and sixth value. So 1, 2, 3, 4, and 5. So my median would be E plus F by 2. And if someone is asking about the lower quartile, I can see these are 10 already. So if I put a line between them, this is my lower quartile, the third value. And on the other side, this is my upper quartile. So in this case, lower quartile is C, upper quartile is H, median quartile is E plus F by 2, and interquartile range is H minus C. So the concept is same, 25%, 75%, and 50%. One by four of total, or three by four of total, or middle. Worked example. For each of the following sets of data, calculate the median upper and lower quartiles. So set A, firstly, they have to be in order. Please say that again.
No, I was gonna say first we have to put that in order.
So first, we put them in order, and I'm using this solved example already. So this is the order. And when we have to find median upper and lower, I'm counting them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So
13 the
1 by 4 of 12 is 3. So let's go with this example is for finding median first. 1, 2, 3, 4, 5, 6. This is sixth and seventh value. Because these are even numbers, so we'll have two numbers at the middle. This line splits them. So 10.10 plus 11 by 2 is 10.5 is the median. So when we find the lower quartile, this is n plus 1 by 4, where n is the number of these data. So 12 plus 1 by 4 is 13 by 4, and 13 by 4 gives me 3.25. So 3.25 is 1, 2, 3, 3.25
So 6.
is between like third and fourth. 3.25 means between third and fourth, and 9.75 means between ninth and 10th. So I'm counting 1, 2, 3. This is third number, this is fourth number. So between these two is 7. And when we count till ninth and 10th, this is 6, 7, 8, ninth, and 10th numbers. So between these two is 11. 12.5, sorry, 12 and 13. So 12.5. And then the interquartile range is upper quartile minus lower quartile.
So 2, like when it ends with a 2 point, like 0.25, then that makes it half of them. And then when it ends at 7.5, it makes them 0.5 of them,
No,
basically.
basically 3.25 is telling you that it is for sure between third and fourth number. If I manually count them, see this, these were already 12. So 1, 2, 3, 4, 5, 6. This is the half line.
Mhm.
Six numbers are on left of this and six are on right of this. And then another half of the lower side and another half of the upper side. Now, because these were even numbers, may I clearly say that these two would make up the median? So average of these two is 10.5,
Yes.
and these two would make up the lower quartile, and average of these two is going to be 7. So basically, this 3.5 is actually telling you that the number lies between third and fourth.
But shouldn't it be 3.5 instead of 3.25 to say that it's half?
That will keep on changing always because this time these were 12 numbers. So 12 plus 1, that is 13 by 4. Suppose these were 100 numbers. So 100 plus 1 is 101 by 4 gives you 2.25. And 3 by 4 would give you 0.75. We just have to reach between those two numbers.
So 3.25 is what, like showing us the word, like which position it's in. So it's the third number, and then it's the 0.25 of it. So you have to add the
Yeah.
0.25. But so to make it the half of like 6 and 8, I know that's like where the lower quartile is, but shouldn't
Let,
it be 3.5 to make it like
let,
half?
if this would have been an odd number data, for example, 11 total numbers. So 11 plus 1 by 2 is 12 by 2 is 6. This clearly shows that it is the sixth number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. If you count it, this is the middle number. See, five numbers are to left of it and five numbers are on right of it. Now, because this was the 11, these were odd numbers. Now, let's see. 11 by 4, 11 plus 1 by 4 is 3. So the third number is the lower quartile. And if we check for the upper quartile, 11 plus n plus 1 into 3 by 4 is 9. And when you count them manually, you'll find these as middle numbers. 6 is already the middle of the grand total. And then on left hand side, we come at the middle. These are two on left of this, two on right of this, and two on left of this, and two on right of this. So this is the middle of upper half. This is the middle of lower half, lower quartile and upper quartile, because these were odd numbers. And when we have even number, we'll always end up with two numbers in between. So why is this 0.25 and 75? For example, this is one complete chunk. So this is clearly 50%. And when we go for 25%, this is 1 by 4 of total. 1 by 4 is 0.25. That is why we are having 3.25. And when we go for upper half, this is 75%. This was 25%. So 75% means 3 by 4 of total. And 3 by 4 is 0.75.
Oh, so that's why it's making it that. Oh,
So whatever it is, for example, we get 7.25. That is just an indication that it is not 7, it is not 8, it is between these two numbers. Let me take a very weird example. Suppose we end up with 7.1. Still, we would know it is between 7th and 8th.
even if it's
If
any like decimal after the 7 is still between them.
yes,
Oh,
suppose we get 15.5. So this is between
with
15 and 16.
But it doesn't mean that it's perfectly in the middle of them. For
Yeah,
example,
because we are dealing with raw data.
Mhm.
So we know it is not 15, we know it is not 16. So we take average of those two numbers. Actually, this is pick and choose. You arrange those numbers in order and then you pick and choose. For example, let's say you arrange your class fellows according to their age or according to their height. So when you arrange them and you're getting a data 3 and 4, 3.25. So you know it's not the third person, it's not the fourth person, it is a value somewhere between them. If you perfectly get a value 3, then it is the third person.
So even if it's 7.1, does that mean it's perfectly in the middle of 7 and 8, so 7.5
It
is
is middle in of two numbers
Mhm.
because we don't have any option. That is the seventh and eighth number. Because we are dealing with raw data, discrete data. In case if it would have been like the classes, then we always take the midpoint.
So it's just the average still, even if it's 7.1 or
Yes.
15.5.
Yes. Another data already arranged in order. This is the worked example. So middle number, this is 1, 2, 3, 4, 5, 6, 7. This is a very small data and I can see that this is the middle number, but let's do that working. So n plus 1 by 2, that is 8 by 2 is equals to 4. Now see, there's no decimal. This is 4. So I clearly know this is the fourth number, that is 14. Then 4, the lower quartile, n plus 1 into 1 by 4. 7 plus 1 by 4 is 8 by 4, that is 7, 8, 8 by 4, that is 2. And for the upper quartile, it is 6. So count, I get this as lower quartile and sixth number 1, 2, 3, 4, 5, 6. I get this as upper quartile.
And IQR is just so subtracted.
Yes, upper quartile minus lower quartile. And if we do it manually, whenever we get a question which is very small data, so I'm just counting it and I see this is the exact half. 3 on this side and 3 on this side. So I'll say my Q2 is equals to 14. Then when I've already splitted them up, I can see these are three numbers. So this is the middle number. So my Q1 is 9. And on the other side, again, three numbers. This is my middle number. So my Q3 is 15. So see, 15 and 9. No matter how we do, we reach at the same number. Now, this is just the different representation. Concept is same. Stem and leaf. That was raw data. And stem and leaf, we know that it is arranged in order already. That is the standard way of representing in stem and leaf. So question says determine the median for each group. Let's see if the total is given. The back-to-back stem and leaf diagram shows the concentration of low density lipoprotein cholesterol in blood milligrams per 100 ml of blood in 70 adults, half of whom are smokers and half of whom are non-smokers. So total is already given. There are 35 to right and 35 to left. 35 smokers and 35 non-smokers. It says determine the median for each group. When we know this is already 35, n plus 1 by 2, 36 by 2, I know this is 18th number. 18th number is the middle number. That would actually mean that there are 17 digits to left and 17 digits to right. 17 plus 17 is 34 and the middle one is 35. So I'm shortlisting the 18th number. Starting with the smokers first. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and this 4 is 18th. I'm referring the key for smokers.
What
11
if
to me. So this is 164. So determine the median for each group. For smokers, leave this is 164. Try for non-smokers. Count till 18th number.
128.
128. So in this case, we move from right to left. So 128 is the 18th number. Non-smokers is 128. Now find the range for non-smokers. The range is
Largest,
maximum. Yes.
smallest. So it's going to be 215 minus 112.
It says non-smokers and smokers as well. Okay.
Oh, so
So
I'm doing degrees. Okay, I'll do the
sure.
non. So that is nine 173 minus 90.
That is 173 minus 90. Yes.
Which equals to 83. And then for the
Mm,
other ones, 201 minus 112, which equals to 89.
215.
Oh, sorry. 215 minus 112. So 103.
Now we are going for interquartile range, so we would need upper and lower quartiles. Now determine the interquartile range. So we already had 35. 35 plus 1. For the lower quartile, this is 1 by 4. So 36 by 4 is ninth digit. And 36 into 3 by 4, 9 3 times is 27th digit. And you would have noticed by now that whenever we have odd numbers, we're getting integers.
Full ones.
5 digits. So we have the middle number is 2.5. The middle number is third. 2.5 means between 5 divided by 2. Sorry, n plus 1 by 2. So 6 by 2 is 3. So 5 digits, I can clearly see 2 are these, 2 are these. So middle number.
Third one.
When we 4 digits, these 2 are the middle numbers. So in even, we'll end up with decimals, and in odd, we'll end up in clear numbers.
Because we're trying to get like the same amount left for both sides.
Yes. So now for interquartile range, I need the ninth and 27th digit. I'm doing for smokers. 1, 2, 3, 4, 5, 6, 7, 8, and ninth is 145. And the
And then
upper quartile is 27th. And do not make the mistake of counting from the lower end. Always count it from the upper end. That was 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, and 27.
180.
180, 35. And same goes on the other side for non-smokers. D part says LDL, whatever that was, low density lipoprotein. Levels of less than 130 are desirable. Levels of 130 to 160 are considered borderline high, and greater than 170 are considered risk. More so for people with medical conditions that increase risk. Using these figures, comment on what the distribution on this time and leave diagram suggests. So if we, let me just write them here. This is 130, and then 130 to 160, and then more than 160. So these are desirable, these are borderline, and these are high risk. So if I look at this, I can see that on smokers, we have more numbers at the higher end.
Yes, at the one like the 60s, 160s.
So yeah, 160. If we just highlight 16 for us, after this, there are more people who are at risk in case of smokers. So we just have to write a statement, and that would be our comment. It could be anything. One would say that no non-smokers are in the safe zone, or one could say that only three people are in the
Uh,
risk zone, non-smokers.
Less than the smokers.
Yes. Exam style practice questions. Let me see. Find the median quartile and interquartile range for each of the following. Make sure you show your method clearly. Okay. Let's do the first one. First of all, we arrange them in order. Doing this first one.
4, 4, 5, 5, 6,
I
6,
see it three. Then how many fours?
2,
Two fours.
and
How
then
many fives?
2,
Two fives.
and
And one six. The second six. No seven and eight. And one, two, three nines. Nine, nine, nine.
then nothing else.
Now find the median quartile and interquartile range. I'm counting them first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Luckily, odd numbers. So 11 plus 1 is 12. Whatever we are going to do is we're doing it 12. 12 into 1 by 4 is 3. 12 into 1 by 2 is 6. 12 into 3 by 4 is 9. Knowing that this is lower quartile, this is median quartile, and this is upper quartile. Now I've already done this for myself. So I'll just quickly count the to the third number. So 1, 2, 3. Third number is 4. Sixth number. 1, 2, 3, 4, 5, 6. Sixth number is 6.
6.
Ninth number. 7, 8, 9. Ninth
That's
number is 9. So median is this, and interquartile range is 9 minus 4, 5.
5.
Show your methods clearly would mean showing the working or anything we are thinking. We just show them on the page.
Like you did over there.
Sorry.
Like you did, like with the blue pen.
Yeah, anyone would have a different style. I just calculated that I need the third and sixth and ninth value for myself. One way was like this in the worked example. He clearly did the median first, then lower and upper, and then wrote into quarter range and all that. Plus, the back of my head, I was having that I have a limited space, so I chose this method. Definitely, um, after this question, we'll be writing the data in order first, and then we'll state that n plus 1 into, like, see, 11 plus 1 equals to 12. Then I'm using that 12 directly. I'm not writing it again and again. Just because of limited space in exam, we'll have only one question. So we'll do it completely.
So showing it like very in detail.
Yes.
Okay.
I'll quickly show you. They're not that long. So we knew this was 12. I say n is equals to 11. So median. median is equals to n plus 1 by 2 is equals to 11 plus 1 by 2 equals 12 by 2 equals 6. Then we count till sixth number and I say median is equals to 6. That was 6. And then lower quartile is n plus 1 by 2 into 1 by 4. Sorry, n plus 1 into 1 by 4. By 2 was for median. N plus 1 into 1 by 4. So that is 1 by 4 into 11 plus 1. 1 by 4 of 12 is 3. And then for the upper quartile and interquartile range.
N plus 1 times 3 over 4. That was
Yes. Let's try question number 2. Try to think about the calculations in each question. Tell you about each situation. Gaiden walks to work when it is not raining each week for 15 weeks. So these are 15 values in total. Gaiden records the number of walks that he takes and the results shown below. Find the median, quartile, and this. So first thing first, we arrange them in order. You can see the smallest number is 2, no threes, and 1, 2, 3, 4. 1, 2, 3, 4.
2
And then
5s,
two fives,
2 6s, 1
two
7,
sixes,
2
another
8,
7,
1 8,
1 8,
and then 2 9s,
two nines,
and 12.
and 1 12. Crossing this out always helps that if any number is left. So now these are 15 weeks. So for median, I know n plus 1 by 2 is 16 by 2 is the eighth number.
So
So we
6.
count 1, 2, 3, 4, 5, 6, 7, 8 is 6. So for upper quartile is 3 by 4 of 16. 4 1 times, 4 4 3 times is 12. So 12th number is 5 5 10 11 12 is 8. And then for lower quartile, this is 1 by 4 of 12, that is third number,
4.
is 4. So interquartile range is upper quartile minus lower quartile.
4.
Upper quartile was 8 and 4. So this is the interquartile range. Let's see if we have any different type of question. Median, interquartile, and suggestion. Okay, we'll discuss box and whiskers, and I'll share these remaining questions for practice.
Should I take a screenshot?
I'll send an email as well.
Okay.
The same which I sent the test.
To my email?
Yeah,
No?
I think I have that one only. Is it
Yeah.
okay if I send it there? Sure. Okay, now box and whiskers. This is a very good method of display which gives a clear idea. Now just see there are no numbers written. And we can see what is the highest value, the lowest value, and where this box opens up. The lower end is the lower quartile, then upper quartile, and then this slit shows the median. So these are five main values: lowest value, highest value, Q1, Q2, and Q3. So this is box and whiskers. I'm going back because we have already solved those questions. And let's say the very last one, this. If I have to draw box and whisker for this question number 2, so I would know that the least value is 2, highest value is 12. And when I draw the number line, let's say this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So least value is 2. I put a dot there. Then I know that the highest value is 12, another dot. Now we know already that the lower quartile is 4 and upper is 8. So 2, 3, 4. Lower is 4. I'm making a slit over there and upper is 8 and closing this. So these whiskers are telling me that the lowest value is at 2, highest value is at 12, median is at lower quartile is at 4, upper quartile is at 8. And we found the median as well, which was 6. 4, 5, 6. So against 6, this is the line. 3, 4, 5, 6, 7, 8, 9, 10, 11, 1. So this is box and whiskers.
So this is what you draw when you know everything, or
Yes. So we would say this is an extra step.
is it necessary?
Depends on the demand of question.
Will the question ask for this, like to do this?
They were clearly stated.
Okay.
If one says find the quartiles, we just do the upper, lower, and middle. And then one says find the interquartile range, we do that. One says find the range, we do that, maximum and minimum. One says display this data on a box and whiskers. So this is how we do. We need to know 5 main values: least value, maximum value, and the 3 quartiles. And this is how we represent the quartiles with a broader box and whiskers in their place.
Okay. It always starts with a 0, right?
It could start from anywhere. For example, this
I
stem
mean,
and leaf.
like the line.
It could start from anywhere. For example, the least value is 110. In that case, we will not start it from 0. For example, let me say my least value is 110 and my highest value is 320. So I will not start from 0. Let's say not 320, 132. If I start from 0, this is what it will look like. This is 0. So this is my least value. This is my maximum value. And mean, median, mode, like upper, lower, and higher would somewhere be here. So this is how it would look like. So what I'll do is, I know the least value is 110. I may start from 100 or 105. And I may make my number line till 140. So I know I have to be against 110 and I have to do against 130. And let's say these are the other values. Let's say this is 115, this is 116, and let's say this is 122, and so on. So you don't need to start from 0.
Okay.
Now, what else could this box and whisker tell you? Let me draw this one. So what do you see?
Well, I see 5 values that we can collect, like the highest and then middle and then lowest quartiles, and then also the
If I say these are marks of physics test, what would you interpret? That there's someone at a very high value.
high,
Because
yes, because
and we if I say these are two different classes and I have this,
oh, so it shows which one scored better.
yes.
Okay.
In this case, we can say there is someone who is at a very lower end, but we know that 25% of the class has scored more than half marks.
Mm-hmm.
Or let's say I can say that this is the mean of this class, because number line is there. Mean of this class is high and mean of that class is very low. And
Yeah,
there's someone who's so if management would see this graph, maybe they will take this decision that shift this student to the other section. Getting the point, the reality, real life check. Because those students might need some extra help. Maybe they're not interested in studying these ones.
they are. I mean, those ones are not, but the second group is.
Yeah. Even if they need special attention, this is the one which is out of the box. So they'll put him here to put special focus on these and have a same strategy. Okay. So I'll share these practice questions along with their answers.
Mm.
And and tomorrow we'll be doing box and whiskers, and that's complete. Oh, where did that cumulative frequency go?
Mm, I think you went too high up.
Actually, I've written this wherever we are doing it. Like when you find these writings, that means we've done it before. I think we discussed it due to some sort of concept, clearing the concept.
Mhm.
We asked some question. That is why we did it. But that is part of syllabus. We'll do it.
Okay.
Maybe we'll cover it in any other chapter. Percentiles, quartiles, yes. Yeah, I did it because of these percentiles and quartiles. How we do it from graph. Yes. Okay. Okay. I'll share it. Yes. Which question was that?
It was 1C and 5C.
1C.
Oh, I mean 3C, I guess.
Okay. What differences do you notice? Try to explain why this might happen. Okay. Pavan is conducting a survey into traffic on his road every
For
Monday
my
for.
I was able to answer this question, but my answer like was wrong. So for my answer, I said there are more cars that pass by his house for during summer. This is because the average for summer is greater. This may happen because there are more cars outside during the warmer weather. But for the answer, it was um I think it was during the winter that it said because it's more consistent. Yeah.
Okay. Look at the interquartile range, part B.
Mm-hmm.
Interquartile range is upper quartile minus lower quartile. And upper quartile is at 75%. Lower quartile is at 25%. So between these two, we have 50% of the data.
Mm-hmm.
So lesser interquartile range means less spread. Understand this. For example, my median value is 40. And if I have a greater spread, let me say the upper quartile value is 60 and lower quartile value is 20. So my interquartile range would be 60 minus 20, that is 40.
Mm-hmm.
But if I have upper quartile at 42 and lower quartile at 38, my interquartile range is 4. That means between 38 and 42, 50% of the data lies between this. So more consistent would mean lesser interquartile range would mean that 50% of the data is around the median.
So less of it has to be around the median. So lesser quartile range, so the result.
Yes, for understand this way. For example, we have made a table for mass of apples. Let's say we bought 3 kgs of apples and we check the mass of individual piece. If they are mostly equal to each other, let's say one of the apple is 200 grams, the other is 205, 215, 200, 208. So interquartile range would be very less because they are consistent, they're close to each other. And if one apple weighs like 15 grams and the other weighs 300 grams, then we have a wide spread. Interquartile range is wide and the masses are not consistent. Wide interquartile range would mean that apples are of different sizes.
Mhm.
Sometimes we could say like, for example, you want to display them. So you'll use those apples which have lesser interquartile range. But if you have to make a juice, that won't matter. No one is looking at it. Was it larger or smaller? You just crushed it. So this is the main.
And for the smaller, what was it again? It was because it was closer to the median, so it was like you said, less spread out, right?
And whenever we answer these, we do check what they are asking for. Part A and B. Basically, they are guiding you through what part C would be
It was the median.
and what the examiner is expecting. He asks the median and then the interquartile range. Let's say, for example, quickly, that one of the data looks like this and the other data looks like this. Let's say maximum and minimum value were same. So the one in option A is more consistent because its interquartile range is less. That means 50% of the data lies between this value. And in the second case, 50% covers a wide range. So that is unreliable.
It's less like the values are more spread out from each other. There's more distance between them.
Yes. Consistency.
So for the results for like summer and winter, because some like winter had less results, it was because it was more consistent and also because people wrote like their transportation more. But for example, for summer, isn't it that there's more results, like more people wrote their like car during summer?
Let me quickly read the complete question. Pavan is conducting a survey into traffic roads every Monday for 8 weeks. In summer, Pavan records the number of cars that passes his house between 8 and 9 a.m. He then repeats the experiment during winters. Both set of results are shown below. Okay, he's counting the number of cars and lowest value is 13 and highest value is 25. And in winters, okay, find the median, then interquartile range, and then the difference. So we come at the answer. So firstly, the median. Median for summer is less is more, and median for winter is less. And then interquartile range for this is 8 and 3.5. Okay. And the lower interquartile range in winter shows that the car numbers are more consistent in poor weather. People either use their own transport or take transport more consistently. Okay. Now for summers, this is for summer and this is for winter. Now, actually, what are we looking at? Interquartile range 8 is this, and this is 3.5. Now, what are we actually missing out? Is that this represents 50% of the people. And then when that spread is actually 8, so we are not sure. For example, Q1 is 15.5 and Q2 is 23.5. This spread is for 50%, but we are not sure. Maybe this is only one of the participant and all other like close to 15.5. Maybe one is 15.5 and all other like close to 23.5.
But we have
But
all the results that he
yeah,
collected.
yes, we do have those results. But we know that 50% definitely lie in very lesser range. So they're more reliable. Like um, in winters, if someone is using the car, other person is also using it. And the third person is also using it. But in this case, because when we are at very lesser end, when we are at the lower end, that means people are not using it. When we are at the higher end, people are using their cars.
So it doesn't even matter that like summer has more like higher numbers. It's just more about consistency.
Consistency. Let's say we talk about our class fellows. I remember, I think you said there are six people in one class. So, for example, we say this is our chart, and in winter, this is summer, and in winter, let's say this is our chart. Now, I've drawn it very less, the higher value, the upper end for winter, I've drawn it very less. But what we can see is that these are 50% of those people, and somehow they do not use and somehow they use. But 50% of these are using it. The
Mhm.
lower end means no use, and the upper end means yes, they're using their own car. So we may say that no use to use. There, no use to use. Very reliable data.
So the second one is more reliable.
Were other parts clear? Like 4C?
Yeah,
Yes.
that was really good. And then the next one is 5C.
Okay, let me have a look at question 5. This is C. Determine the interquartile range for one city, one city. I think that would be D if you are talking about 5.
No, 5C. Because D I was good with it. But 5C.
5C is determine the interquartile range for city traffic and open road driving. Simply upper quartile minus lower quartile.
I know, but my results they were like I don't know why they were incorrect because even though I redid it.
Okay.
Because for
Okay,
their
let me
results they
update it.
had decimals.
Mm, The the fuel economy of 18 cars and models and so on. Okay. And 3 by 4 of 19. So 19 divided by 4, I'm getting 4.75. 4.75. That means I'm interested in fourth and fifth number. So this is one, two, three. Fourth number is 1, 2.1, and fifth number is 1, 2.1. Divide by 2, so 12.1. Upper quartile and lower quartile, and for the upper quartile, I'm having 14.25. That means I'm interested in 14th and 15th number. So this was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14th number is this, and 15th number is this. So we get 15.8, and interquartile range is the difference. 15.8 minus 12.1, I'm getting 3.7.
And their result was not that.
Okay. Even numbers 18. So if we split, this is 9, this is 9. Split 4, 4, fifth number, and 4, 4, The fifth number, 1, 2, 3, 4, 4, 4, 8, 1, 9, 10, 11, 12, 13, 14. 14th number and fifth number. 1, 2, 3, 4, 5 is 12.1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15th number is 15.9. 15.9 minus 12.1. Is this the answer? 3.8.
No,
Why? No, let's check.
there's like three decimals that follow after three.
Determine the interquartile range for city traffic and open road. Okay, I've done the second one. Let's see. 5C 3.65.
I guess you
3
could round it, but it's still
point
an,
six five.
how are they finding the numbers to round?
We should be getting the same number. 3.6. Let me recheck. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Interquartile range upper minus lower. 15.9 minus 12.1 is 3.8. 12.1 and 15.8. 3.7. Okay, 12.1. And this is 15.7, and that was 0.25. So 15.7, and the difference is of 0.2 plus 0.2 into 0.25 is 15.7 plus zero point 0.2 into 0.25 is 15.75, and 15.75 and 12.1. 15.75 minus 12.1 is 3.65. What answer are you getting? 3.7?
For the open road, I got 3.7.
That's correct. I'll explain what this book is actually doing. How they give this answer, these answers are computerized form. I'll explain how I got this 3.65. Now see that we have these two data, upper quartile and lower quartile. When I'm working for the lower quartile, these two, 12.1 and 12.1, lower quartile is exactly 12.1. Any doubt?
No,
And then the upper quartile says that we need 14th and 15th number. I'm getting 14.25. 14.25. There was no ambiguity in lower quartile because both the numbers were exactly same. 12.1 and 12.1. Both the numbers were same. There was no difference. And 14.25 means I'm looking for 14th number and 15th number. Now, when I look for 14th number, the number is exactly 15.7. And when I look for 15th number, the 15th number is 15.9. Now, this is what computer does. Computer is telling you that this is 14.25. That means he's saying this is your upper quartile. And what we are doing, we're taking this value, middle value. So he's taking, because of this 0.25, for example, 15.7 first value, 15.9 second value, and I'm dividing it into equal fours. So it says 14th number, 14.25, 14.50, 14.75, and 15th number. Computer says this. What we are doing generally, we are always coming in the center. Even if it is 14.1, even it is 14.9. So we are looking for 14th and 15th number and we are coming in between. So the computer does this. He is now checking that this is 15.7. The difference is 0.2, but we need 0.25 section of that. So into 0.25, which is making 15.7 plus 0.25 into 0.2 is 0.05. 0.05 making it 15.75. That is why the difference is of 0.65, 3.65.
Oh, but when they're checking it, doesn't matter, right? I don't have
Questions.
to write like the
No,
computer.
no, you don't have to worry. You have to be between those two numbers.
Okay. And it's the same for the city traffic, I guess. I don't have
Yes.
any more questions.
I'll double check this, but I'm very sure because this is not the first question we're doing.
Mhm.
We did many during the class and we got the correct answers. I'll just cross check with the syllabus.
Okay.
Okay, our next topic is understanding measurements.